In the past few decades, humanity has achieved remarkable advancements in space exploration, instilling a sense of confidence in our ability to avert potential threats from outer space. But this conviction was profoundly altered by the arrival of Oumuamua, our first interstellar visitor. In a recent episode of the Joe Rogan Experience, renowned podcaster Joe Rogan and his guest revealed declassified images of this mysterious flying object. Now, we are left wondering, are aliens responsible for sending this extraterrestrial message? And if so, why is NASA concealing this information from the public? Let's dive into the truth behind the mysterious object that visited Earth. Since the Soviet Union launched the first artificial satellite on October 4, 1957, humanity's perception of space has been forever transformed. The launch of Sputnik 1 opened the doors to future explorations and ushered in a new era of scientific advancement. Following this groundbreaking achievement, subsequent satellites such as Explorer 1, the Hubble Space Telescope, and the International Space Station have propelled scientific progress, revolutionizing our understanding of the cosmos. After 60 years of space exploration, scientists did not anticipate encountering something as astonishing and unfamiliar as a mysterious, unidentified flying object within the vicinity of Earth. The unexpected arrival of Oumuamua caused a significant stir within the scientific community, leading to extensive investigations to determine its nature. While scientists initially leaned towards a natural explanation, some interesting new discoveries point to the possibility that the mysterious object spotted in 2017 could potentially be an alien probe. To delve into this notion, popular podcast host Joe Rogan revealed the classified images of Oumuamua alongside Israeli-American theoretical physicist Avi Loeb. Together, they meticulously examined the evidence that NASA had supposedly hidden. However, before delving into the captivating details, it's important to understand some interesting things about how Oumuamua was initially discovered. Just 9 years after the University of Hawaii's Pan-STARRS 1 telescope achieved a remarkable feat, astronomer Rob Warwick, utilizing the Pan-STARRS 1 telescope, observed a breathtaking celestial event on a crisp October night in 2017. Initially mistaken for a typical comet or asteroid, further examination revealed a remarkable truth: the detection of an interstellar object in our cosmic vicinity. This cosmic traveler, with its slanted orbit and incredible velocity, led scientists to conclude that it originated from beyond our solar system. This mysterious object needed a name fitting for its observed qualities, and scientists settled for Oumuamua, meaning a messenger from afar. As astronomers studied this cosmic messenger, some shocking data were extracted. Oumuamua exhibited irregular brightness fluctuations that defied easy explanation, indicating an elongated shape 5 to 10 times longer than its width. Astronomers employed the light curve as a tool to decipher Oumuamua's shape. This luminous graph traced the object's changes in brightness as it tumbled gracefully through space. Surprisingly, Oumuamua appeared brightest when observed from its broader side, suggesting dimensions of approximately 377 feet in length, 364 feet in width, and 62 feet in thickness. Its albedo or sunlight reflection stood at 0.1, a characteristic commonly seen in carbonaceous asteroids. The elongated, cigar-like form of Oumuamua sparked numerous questions and diverse theories. One hypothesis suggested that tidal forces from a close encounter with a star shaped its unusual form, but this explanation failed to account for the exact dimensions of the cosmic oddity. Attention then turned to the asteroid 25143 Itokawa, encountered by the Japanese Hayabusa spacecraft in 2005. Although similarities existed, Oumuamua remained distinct, lacking the comet-like tail seen in objects from our solar system. Beyond its shape, Oumuamua's trajectory through our solar system added to the mystery. Contrary to expectations, it ventured exceptionally close to the Sun before continuing its journey below the planetary plane at an astonishing velocity of approximately 196,000 miles per hour, surpassing any human-made object. This rapid motion led to a hypothesis published in the monthly notices of the Royal Astronomical Society, suggesting that Oumuamua originated from a binary star system. Lead author Alan Jackson, an astronomer at the University of Toronto, proposed that over 95% of rocky interstellar objects like Oumuamua likely come from binary systems, where the gravitational interplay between two stars could propel them. In the realm of intriguing and controversial speculations, the idea of Oumuamua as a hydrogen iceberg emerges. This concept stems from Oumuamua's peculiarities. The hypothesis suggests that Oumuamua may be enveloped in a thin molecular layer of hydrogen, the lightest and most abundant element in the universe. This hypothetical hydrogen ice could shield a denser core, possibly composed of metal or rock. The audacious notion proposes that as Oumuamua journeys through space, the gradual sublimation of this hydrogen layer could account for the unexpected accelerations and spins observed. Another captivating hypothesis suggests that Oumuamua's remarkable velocity is a result of encounters with celestial bodies within its home star system. In this cosmic choreography, Oumuamua may have interacted closely with planets or massive objects, utilizing them as cosmic gravitational slingshots to achieve its extraordinary speed. This gravitational assist, a well-known phenomenon in space exploration, resembles the maneuvers employed by interplanetary missions to conserve fuel and gain momentum. It is speculated that Oumuamua engaged in celestial dances, harnessing gravitational forces to propel itself through the vast expanse of the universe. Scientists are currently developing a mission to intercept Oumuamua and study its features before a second visit to Earth. This space adventure is all about exploring the mysteries of these interstellar visitors. Like detectives, scientists are gearing up for a cosmic road trip, using high-tech gadgets and brainpower. The planning stage is in full swing, with experts from different fields like astrodynamics and imaging working together to figure out the best way to send a spacecraft to catch up with Oumuamua, which is no small feat considering the mind-boggling distances involved. The spacecraft itself is like a high-tech detective, armed with tools to analyze Oumuamua's secrets. Engineers are making sure it can handle the challenges of space travel and gather valuable information during its close encounter with this interstellar wanderer. Imagine the excitement as scientists fine-tune the spacecraft's trajectory, making sure it dances through space with precision. However, Joe Rogan's guest is focused on revealing certain mysterious details of Oumuamua using the recently declassified images. Keep watching to understand his take. But let's quickly explore the nature and origin of Oumuamua. Recent studies have uncovered fascinating details about Oumuamua, a mysterious object from interstellar space. Oumuamua's outer layer, akin to a cosmic shell, is composed of carbon-rich materials that solidified during its extensive journey, bombarded by cosmic radiation. Beneath this protective exterior lies a remarkably dense core made primarily of rock, possibly with traces of metal. What sets Oumuamua apart is its distinct lack of water or ice, making it unlike typical comets or icy celestial bodies. Additionally, Oumuamua's surface exhibits a reddish shade, a result of several years of exposure to cosmic rays. The elongated shape of Oumuamua has intrigued researchers, leading to speculation about its origin. Some experts proposed that it could be a fragment of a larger celestial body. If Oumuamua broke off from a larger object due to a collision or violent event, it may have acquired substantial velocity during the separation process. This suggests that Oumuamua's high speed is not inherent but a consequence of past events. While comets can achieve similar velocities, they typically display residual gases and dust due to their volatile composition. In contrast, Oumuamua lacks these characteristics, distinguishing it from known cometary objects. Comparisons to asteroids and rocky objects in our solar system further emphasize the exceptional nature of Oumuamua's velocity. Interestingly, some experts propose the intriguing possibility that Oumuamua may not be a natural occurrence at all. Instead, they speculate that it could be an artificially crafted object meticulously created by an advanced extraterrestrial civilization. Yes, we're talking about aliens. According to this theory, Oumuamua could be part of an incredibly advanced alien spaceship or equipment designed for exploration. Its elongated structure could enhance its resilience during interstellar travel, while its propulsion system might enable precise maneuvering through the cosmos. Other researchers, such as Wesley C. Efrad, have been diligently studying Oumuamua's puzzling rotation. By analyzing brightness measurements from multiple telescopes, they have discovered that no single rotation period can account for the observed variations in brightness. Instead, Oumuamua appears to be tumbling in an excited rotational state, exhibiting a peculiar and irregular motion never seen before. This means that unlike most celestial bodies, which have a relatively stable spin around a single axis, Oumuamua is rotating chaotically around multiple axes. This irregular motion has been a focal point for astronomers since it was first observed, as it challenges our understanding of the behavior of objects in space. Astronomers have made significant observations that shed light on Oumuamua's spin. By meticulously analyzing data collected from various telescopes, they have determined that Oumuamua completes a full rotation approximately every 7.3 hours. This is considered a relatively fast rate, especially when compared to other objects in our solar system. For instance, asteroids and comets often have rotation periods ranging from several hours to several days. The fact that Oumuamua spins so quickly adds an extra layer of intrigue to this interstellar visitor. The varying brightness of Oumuamua as it spins suggests that different parts of the object reflect sunlight to varying degrees, adding to the mystery. This phenomenon is known as light curve variability. When astronomers plot the brightness of Oumuamua over time, they observe fluctuations that correspond to its rotation. These variations in brightness indicate that Oumuamua has an elongated, irregular shape, with some surfaces reflecting more sunlight than others. The precise nature of these surface features remains a topic of active research. One theory to explain Oumuamua's irregular rotation is the spin-induced outgassing theory. According to this idea, volatile substances beneath Oumuamua's surface could be sublimating, turning from a solid to a gas when exposed to solar radiation. This process would create small jets of gas that act like thrusters, subtly altering Oumuamua's rotation and contributing to its chaotic tumbling motion. This theory is intriguing because it suggests that Oumuamua may have a composition that includes ices or other volatile materials, similar to those found in comets. However, this theory is also controversial, as Oumuamua did not exhibit the typical tail or coma associated with comet outgassing. Another hypothesis to explain Oumuamua's tumbling is related to a possible collision in its distant past. Some researchers speculate that Oumuamua could have experienced a significant impact with another celestial object, possibly during its journey through the interstellar medium. Such a collision could have imparted a complex spin to Oumuamua, resulting in its current irregular rotational state. This scenario would mean that Oumuamua's tumbling motion is a remnant of a dramatic event that occurred long before it entered our solar system. Further complicating the picture is the possibility that Oumuamua's irregular motion might be due to its elongated shape and structural properties. Unlike spherical objects, elongated bodies can have more complex rotational dynamics. For example, an elongated object with an uneven mass distribution can experience variations in its rotational speed and axis over time. This could explain the observed changes in Oumuamua's brightness as it spins. Adding to the complexity is the fact that Oumuamua's shape and motion do not easily fit into our existing categories of celestial objects. It lacks the characteristic features of both comets and asteroids, prompting some scientists to propose that it represents a new class of interstellar objects. This classification challenge underscores the importance of continued observations and theoretical modeling to understand Oumuamua's true nature. In addition to the spin-induced outgassing theory and the collision hypothesis, some researchers have considered the possibility that Oumuamua's tumbling motion could be influenced by gravitational interactions. As Oumuamua travels through space, it may pass close to other celestial bodies whose gravitational fields could alter its spin. These gravitational interactions, although subtle, could contribute to the observed irregularities in its rotation. To gain a better understanding of Oumuamua's complex behavior, scientists are employing advanced techniques and simulations. By creating detailed computer models of Oumuamua's motion and comparing them with observational data, researchers hope to unravel the mysteries of its rotation. These efforts are crucial for interpreting the signals we receive from interstellar objects and improving our broader understanding of the dynamics of celestial bodies. Oumuamua's excited rotational state and peculiar tumbling motion present a fascinating puzzle for astronomers. The fast rotation rate, coupled with varying brightness and irregular motion, points to a complex interplay of factors that influence Oumuamua's behavior. Theories such as spin-induced outgassing, past collisions, and gravitational interactions offer potential explanations, but each comes with its own set of challenges and implications. As research continues, Oumuamua serves as a compelling reminder of the vast and largely uncharted mysteries that await us in the depths of interstellar space.